Hi everyone. How are you? It's nice to see you again. It's an evening for us over here in the United States, but we know that many people who are watching this live solve are from all over the world. Well, I'm Po-Shen, and I'm very happy and proud to be collaborating with Math Kangaroo USA on some terrific questions. Uh, Many of you have come to our live solves before, so you know that the reason we like to do this is because we find that the creativity of the questions in Math Kangaroo is just quite fantastic. We see lots and lots of different math competitions out there, and Math Kangaroo is one of them that spends a lot of time every year coming up with things that are pretty good. My background, I'm Po-Shen Lo. My background is normally I'm a math professor at Carnegie Mellon, but also, as many of you know, we run an entire online school called Live. And today we'll have two incredible people who are instructors on Live leading this live solve. But before they start, I want to introduce a representative from Math Kangaroo because we're always happy to help share Math Kangaroo's insights from Math Kangaroo's own people. The person I'm about to introduce, his name is Sahakian.
Mhm.
Samvel Sahakian. Oh, that makes me guess. I wonder if he is from Armenia.
Yes.
Yes. Because I've known many wonderful mathematics people from Armenia, and when I see that last name, it looks like Armenia. So that
Hey,
wasn't in his
great to
introduction
hear.
that I got, but I'll tell you, he's from Armenia. He's the founder of Mathico School, and he has been a dedicated Math Kangaroo state director and center manager for 6 years. He's a mathematician and an inventor in the IT sector, and he has worked with many different competitions. He's designed programs for contests and Olympiads, from Math Kangaroo to AMC 8, 10, and more. And he has students who have been winners of national and state competitions. He he got interested in math quite early in his life, and he became the winner of several math Olympiads and competitions, including a national Olympiad, which I now know is an Armenian national
Yeah,
Olympiad.
yeah.
He has a master's degree in computer science and mathematics from the State University. Oh, yes, it's from Armenia you are, and data science from Cornell University. But with that, Samvel will take over and say a few comments about Math Kangaroo before popping it back over to me.
Okay, hello everyone. It's honor to be here. It's great to be here, and welcome everyone to Live Solve. It's a great initiative, and I want to talk about Math Kangaroo a little bit. I help running Math Kangaroo here in New York State, and what I want to tell about Math Kangaroo competition. The first thing that comes to my mind when someone asks what is Math Kangaroo, I say it's fun and challenging. It's fun and challenging. It's not just regular math that, though regular math is beautiful, of course. Um, However, Math Kangaroo is a little bit different. It's a very cool math contest that there are puzzles that you need to think about. So there are problems, not exercises. And to solve any puzzle, you need to use all your imagination, all your creativity. And then, and during this competition, which I invite everyone to join the competition, it doesn't matter you had experience before or know how much you know the math topics, concepts, because Math Kangaroo problems and puzzles everyone can solve relying on a pure logic. This is what Math Kangaroo problems, this is what Math Kangaroo contest, and this is for everyone. And I really encourage everyone to join and have fun. And additionally, what I want to tell, this year Math Kangaroo is in March. I believe registration is already closed. However, in a couple of weeks, in 2 months, the registration for the next Math Kangaroo will be open. And also just wanted to tell, we are doing Math Kangaroo classes and Math Kangaroo summer camp. So welcome to join, to go out to our website and find more information. And what I want to tell more, this is again great initiative, live solve session. Enjoy.
Thank you so much, Samvel. It's always nice to be able to have the comments about Math Kangaroo from the official Math Kangaroo people. We are happy to help them advertise what they do because we think that they do really, really good things. You might have noticed that if you were watching this, that whenever I'm on or the next two live instructors are on, anytime you type a message to chat relay, it's going to come down here. So I actually think while I'm still here, let me see, can we practice this? You just send a message in Zoom to chat relay and tell me what you ate for lunch or dinner or something. And then you'll see that messages come through, and you'll also see that not every message comes through. The way it works is that every second, at most one message comes through, but you can have more luck than other people. Yes, that's right. You can have more luck than other people if you say things that are mathematically good. Then you get these things called stars. Okay, you'll notice that as you make more and more good math comments, you earn more and more stars. That increases the chance that when you send a message into the chat relay, people will find out that you ate dumplings or pizza or whatever it happens to be. Unfortunately, if you say things that are not so good, you get negative stars, and that's like a bad thing. But anyway, with that, I'm going to go and pass this off to the two people who are actually going to be running this show. They are actually absolutely awesome. It's Alan and Corey, and they're going to introduce each other. Alan, why don't you take it away from here?
Okay, am I on the? Oh, okay, here I am. Okay, guys, so my face is slightly blocked by the chat relay because you guys are already typing a lot of messages in there. But, yeah, we're really glad that everybody's here today, and I'm just gonna go ahead and introduce Corey. So Corey is the guy on the left here. So let me go ahead and do this. So Corey is a current senior at Lexington High School, so he's 12th grade. He has been involved in a lot of math competitions since middle school. So actually, I also have been, so we've both been doing math for a pretty long time. And he's participated in many math competitions and Olympiads, and he likes helping others. And besides math, he likes spending time outdoors, playing sports, and being with his friends. So if we could all just quickly say hi to Corey in the chat, that would be much appreciated.
Hi
And
guys,
yeah,
hi everyone. You're gonna be stuck with me for an hour, so hello, hello. Alrighty, so now my partner today will be Alan. So Alan is the 2022 Math Counts national winner and the 2023 mock and 2024 IMO TST qualifier. So he's really crazy. He also captains the math team and co-captains the computer science club at his high school. And outside of math, Alan enjoys robotics and engineering and dreams of joining the varsity soccer team and dribbling like his idol Messi. So can everybody say hi to Alan in chat too?
hello everybody. Oh,
Hi.
also I did preemptively put a little bit of a high message up here, but I'm starting to realize maybe that wasn't necessary. So I'm just gonna go ahead and erase that real quick. All right, so hello everybody. Okay. Um actually, okay, I'm just gonna make some quick conversation real quick. So, Isaac loves Liverpool. Um I actually okay, I don't know why I just decided to say that, but I do love Liverpool as well. Corey, have you done Math Kangaroo before? And what are your
I've
thoughts?
done the live solve before, and I think they're really cool. So I feel like when I was younger, I only saw like AMC 8, but I think like having a bunch of other like math competitions are actually really nice because doing the competitions really gives you a lot of practice and it shows you a really different flavor of questions, and I quite like them. So I'm excited to do another live solve today.
Yeah, so this is actually my so this is my second live solve. My actually I did a live solve like a year ago, but my memory is really bad. So like y'all's memories are probably better than my memory, and I can't remember if I did like two or three. But that being said, we uh we need to get started with the math now because it's been 8 minutes since you guys have joined this meeting, and I know you guys might be getting a little bit bored by our endless conversation. So let's get into it. So if everybody's ready, we're gonna get started in three, two, one, and let's go to the first question. Okay, so the way this is gonna work, at least the way that I'm gonna do this probably is I'm gonna talk about. Ooh, uh, are we both on the screen?
Right now you're spotlighted, so it'll be okay.
Oh, it says It looks to me as though you're spotlighted. Okay, I'll just assume that everybody can see me. Okay, so here we go. A shape is made of equal-sized pentagonal tiles. Which of the following tiles can be placed in the empty space to produce two closed curves? So let me zoom this image in real quick. And actually, wow, Pratap, is it Pratap? Hopefully I'm not mispronouncing that. It says B. So let me take a look real quick. Okay, so if you can't see what I'm drawing here, just put this in the chat. Let me know if you can't see what I'm drawing. But I look at this larger diagram, and the first thing that comes to my mind is actually, because I'm looking for two closed curves, right? I'm looking for two closed curves that's basically like, let's say two circular objects, right? They have to be separate from each other. And the first thing I'm seeing is that I can just do this. I can draw something like what you see right here. I don't know if you guys can see that, but I can draw something like that. And if I look at the answer choices, oh, I need to move this actually. If I look at the answer choices, at first glance, I'm not seeing anything like that. Okay, people are saying C. Oh! Okay, wait. Okay, you're right. Everybody is saying C. And let me actually go over why C is the correct answer here. So if I erase these diagrams, oops. Oh. I am not used to this moving mechanism, it seems. Okay, let me get rid of that. Okay, yeah, the answer is C. You guys actually did that faster than me. But basically, the shape that we have to put right here, is actually an upside down pentagon. And answer choice C is an upright pentagon. And if you reverse answer choice C, then you see that there's a small square in the corner, and then you have a longer segment on the side. And so that's just answer choice C. So yeah, everybody in the chat who found that much faster than me, good job. I haven't seen these questions before, by the way, so it appears that I am pretty bad at math, and you guys are better than me, so woohoo to that. Okay,
Hey,
Corey.
yeah. So yeah, answer choice is C. So good job, everyone. And I think this is a statement that you guys are really, really good at these puzzle type questions, which is great. So now let's take a look at the next one. And the next one, honestly, we're starting off with some easy ones, I would say, because number 4 looks pretty straightforward. I look at this and it just looks like a bunch of numbers. So let's speed through this. So first, I mean, looking at this question, we would just do out the multiplication and the addition and do out all the questions, right? So let's start with first. Oh, can everybody see me? Just, yeah,
Oop.
hopefully. So first, on the bottom, I immediately see that there is a 0. 2 times 0. So I can just cancel that out. And now, I mean, this question is fairly simple, so I guess I'll just go through it. It should be 20 times 24, and then I just divide by 2 times 4. And I mean, okay, well, 2 times 4 is 8. So I'm dividing by 8. And 20 times 24 divided by 8, well, that's just 20 times. If I take 24 and I divide by 8, well, I'll just get 3. So 20 times 3, that's just 60, right? So this question is fairly simple. And I see everybody saying D in chat. And yeah, the answer is just D. And to save time for some more cooler questions at the end of this, let's just move on. Yep, 60. Actually 60. You're right. Good job, guys.
Okay, so next question, I guess. And actually, Corey, that was pretty fast, unlike mine.
Yeah.
So let's see if I can do this one even faster.
Okay.
Alright, so Ria has 3 counters marked 1, 5, and 11, and she wants to place them side by side to make a 4-digit number. So how many different 4-digit numbers can she make? So really what I'm going to do on this question is I'm just going to separate them by commas, right? So one number I could make, for example, is 1, 5, 11. So 1,511. I could also do 1, 11, and 5. So 1,115. Now, what else can I make? Well, I can put the 11 first, and I can do 11, 1, and 5. But these two are actually the same. So I'm just going to cross that out. I can do 11, 5, and 1. That gives me a third new number. And then finally I can put the 5 first, right? So I can put the 5 first, and I can get 5, 1, 11. And finally, I can get, let's see, I can get 5, 11, 1. But 5, 11, 1 is also the same. So actually I only end up with 4 numbers, 1, 2, 3, 4, because I have 2 duplicates. I have 2 duplicates, so the answer is B4. Okay.
Yeah, great. So that was also really fast, but don't worry, guys. I think that it'll get a little bit trickier as we go through. And we have a lot of questions today, so we have a lot of time. We've got like 45 minutes left. So we'll slow down soon, but let's take a look. Okay, so this is a little bit more of a fun one. I quite like these questions. So it says the weight restriction notice for an elevator says that you can either carry 12 adults or 20 children. And according to the weight restriction, what is the largest number of children that can ride in the elevator with 9 adults? So basically, we've got this elevator, right? And what the question is saying is that the elevator can take 12 adults or it can take the same elevator can take 20 children, like that. And right now, I know that there's already 9 adults in here, and I want to know how many children can I take? All right. So I see a bunch of you guys are saying the answer, and you guys are all saying C, 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 C. So that's great, but let's try and change it up a little bit. Instead of saying the answer, which is good, you guys can say the answer, but after you guys type in the answer, you guys should try and type a bit about how you did it, like maybe like like some sort of like thoughts, or maybe like has to be short though. Yeah, yeah. So Emma says ratios. Great job. Yeah. Figure out how many like adults and children there are. So right now we can have 12 adults or we can have 20 children. So we can see that there's actually we can take way more children, right? Because the children are a little bit lighter. So let's try and see like what the conversion between adults and children are. Adults and children. Okay, well, I know 20 adults is equal to, I mean, 12 adults is equal to 20 children, but let's try and reduce that ratio a little bit. Let's see what, well, let's just divide here. Let's divide by 4. So I know that 3 adults is going to be 5 children, right? Because of ratios. I have this sort of conversion, and I know that, well, if I have 1/4 of the adults, then I should also have 1/4 of the children. So we know that essentially that 3 adults is going to be equal to 5 children. And here I have 9 adults, right? So how do I know how many children 9 adults is worth? Well, let me just scroll down a little bit. Well, let's just multiply by 3. So if I multiply by 3, I'll know that 9 adults is going to be 15 children. Okay, so what does this mean, guys? 3, yeah, I see Subramian says that 3 adults to 5 children. Exactly. So right now I have 9 adults, which is equivalent to 15 children. And I know that in total I can have 20 children. And right now I have the equivalent of 15 children. So how many more children can I get? How many more children can I get? Yeah, nice. All of you guys were saying B, so if we go back, we look, B is going to be, I mean, C, wait. I think this question should be 5, right? This question should be C. What do you guys think? Hey, can you guys all type your answer, the answer you guys think is right in chat? Yeah, yeah. 20 minus 15 is 5. So it should be C. Nice. So this question, exactly. So basically what we did is we just converted between adults and children, and we saw, well, I have 9 adults right now. That's the equivalent of 15 children. And I can have a total of 20 children, right? 20 children. So I have 5 more children I can put on. So 9 adults and 5 children is going to be the same as 20 children, which is great. Great. So Alan, do you want to lead the next question? Oh, wait. Yeah, this question is C5. Perfect.
Alright. I think I do notice, is the camera switching for you guys actually? Just a quick technical question. I think I noticed the camera switching occasionally.
Yeah, I think it's because your mic has a lot of static, so
Ah, okay, okay, okay. then okay, what I'm gonna do to fix that issue is I'll mute when Corey is talking so that you guys don't have to see my face constantly. Um, so yeah, okay, hopefully that fixes the problem. Let me get to the next question real quick. I noticed some of you guys are saying, when will it get harder? Like Corey said, I guess this is just an indicator that you guys are kind of good at math. So let me try to get through these as fast as I can, alright? So let me see. The length of a set of 4 well-parked supermarket carts, so they're all meshed into each other like this, which fit into each other, is 108 centimeters. The length of a set of 10 well-parked supermarket carts is 168 centimeters. What is the length of a single supermarket cart? Okay, so this question right here. Supermarket carts, when you look at them, they're like really complicated, right? Like there's this massive mesh of like metal right here, but that mesh of metal is completely irrelevant. So let me look at it this way. A supermarket cart is really two sections, right? There's A, the front, and then B, there's the actual cart part of the supermarket cart, right? So when I have a single supermarket cart, the length is just A plus B. Now watch this. If I have a second supermarket cart, then what happens? Well, the second cart, the only part it is contributing is the front, right? And then the first cart has its full length contributed. So when I have two supermarket carts, or that should be longer actually. When I have two supermarket carts, the length is A plus A plus B. A plus A plus B, so 2A plus B, right? So now let's actually go back to the original question, right? In the original question, I have 4 supermarket carts contributing 3 A's. So the length of 4 supermarket carts, the length of 4, L sub 4, is 3A. Wait. Oh, wait a minute. Oh, give me a sec. Okay. Yeah, the length of 4 supermarket carts is 4A plus B. Because there's actually a front part to this cart right here. So there's 4 front parts. 1, 2, 3, 4. And then the last cart also has its original front part included as well. So its length 4 is actually 4A plus B. So the length of 4 is 4A plus B, and this is equal to 108. And now when I have 10 supermarket carts, well then there's going to be 10 fronts, 10 of A, and finally there's going to be one back part, 1 of B. And this is equal to 168. And so we basically add on 6 front parts. Like Helen says, 6 front parts. Sorry, I haven't been looking at the chat too much because I'm getting kind of carried away. But we have 6 front parts, and those 6 front parts add on 60 centimeters. So every front part is 10 centimeters. So that means A is equal to 10. Every front part is 10 centimeters. And now the length of 4 carts, 4A plus B, is 108. And if the length of one front is 10, A equals 10, then that means I have 40 plus B equals 108. So if I move this box section up here, I have 40 plus B equals 108. And so B is equal to 68. B is equal to 68. Hopefully you can read this handwriting. But basically, the front part is 10, the back part is 68, the total must be 78. Okay.
Great,
Court.
great, great.
Oh, do you have any thoughts?
No, I think that was great. I did it in a similar way, but it was also really confusing to me. I kind of like, I think thinking about it in front and back is really nice, but like I also thought of it as like just like the overlap and the non-overlap part because yeah. But I think that way's better, honestly. My way's a little weird. The algebra was the same though. But see, guys, these questions are getting a little bit harder now, and that one was hard because it was like this weird shape. But now we have a hard question. Like honestly, This one's pretty tricky. Um, let's see. How are we gonna approach this? We have another slide of just the shapes. Let's just first read the question. So it says that Justin can make a 4x4 square where the sum of the numbers in all four rows and all four columns are the same from the three pieces shown, blah, 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 right? So we got these three pieces here. And we want to make this 4x4 square, but these pieces, um, I don't know if we can move them or not, or we can shift them or not, but let's just find out. So these three pieces, they don't make up the full square. We don't even know where they belong yet. But look, I'm gonna write this on a new slide. So we got this L shape, we got this bigger L shape, and we got this sort of T shape. So let's remember that. So now I'm first gonna draw my 4x4 just right now. Just draw it real quick. Whoops, there we go, there we go, there we go. Here's a 2x2, and then here's a 4x4. Great. So the first thing to think is, well, if I have a square and if I'm allowed to rotate everything, I might as well just fix the rotation. And the way to do it is I want to fix the biggest thing. So the biggest thing is this big L shape, right? So um like this L shape, it could look like this. It could look like that. It could look like this, or it could look like this. Like we don't know what the orientation is, but let's just assume that the orientation is like that. But we don't know whether or not it's here, or it's here, right? But let's just assume that it's long horizontally for the biggest piece. Because if we can set in stone the biggest piece, that'll make, I mean, that'll make it easier because we get some more stuff that's concrete, right? Great. Can you guys type in chat relay? I don't know if chat relay is still working for you guys because I don't see anything. Feeling a little lonely, guys. Oh, is chat relay working, guys? Oh, hi,
Yo,
hi.
what happened?
Working. Perfect, perfect, perfect. Hi. Okay, so guys, now we know that we want it to be horizontal, right? So one way we can do it is I can put this piece like that, right? Or I can shift this piece down to be here, or I can shift this piece down to be here. But guys, let's look at this. Do you see this elbow piece on the side? This elbow piece right here? It, if I have my orange piece is here, can I even fit my elbow? Ooh, I have an elbow piece to fit, right? And I have a T shape. Like, if you just look at it, like if I fit the elbow shape here, like there's no place for me to fit the T shape, right? Because the T shape could go to here, but there's no space for the elbow shape. Even if I rotate it, like, look, let's say, let's say my elbow shape looks like this. It's rotated, right? But look, I have no space for my T shape. I can move it here. Oh, what the? I can move it here, and look, I still don't have space for my T shape. There's no way, if you can kind of look at it, there's no way for me to fit both of these two shapes inside of a 2x4. There's just like no way, right? Like, can you guys agree that there's no way to fit these two remaining pieces inside of this 2x4? Because obviously I can't fit it in the bottom, right? Yeah, that makes sense. So we can't put this orange piece here. And for the same reasoning, we can't put this orange piece here because look, guys, if I draw an elbow shape that looks like this, like how am I gonna fit my T shape? You know, the T shape right here, like I can't fit the T shape into this picture. It's impossible. Like I can move it around, I can flip the orientation. I can flip the orientation. Like I just can't fit the T shape. So that means that the only way is for this orange piece to lie uh, horizontally like this, right? So that's a great thing, guys, because there's two parts of this question. First, there's the sum, right? All the rows and all the columns are the same sum. And second, it's where the pieces lie. And that's the core of this question, just these two pieces of information. What's the orientation of the shapes and what are the numbers inside of the squares? Well, let's look at the numbers really quick. Okay, it's a 4x4 square, and I want to know all the rows and all the columns are the same. Guys, very conveniently, we have one row right here. Has to be a row because we're fitting it in a 4x4, right? So this row is 2 plus 1 plus 3 plus 1. So guys, what's the row sum? What's the column sum? Can you guys type in chat? What's the row sum and what's the column sum? Should be easy, guys. Come on. 7, exactly. 2 plus 1 plus 3 plus 1. It should be 7. So as an example, guys, as an example, let's look at this. These three, remember, it's a 4 by 4, right? So these three were missing one. What does that other one have to be? What number does the other one have to be? I have a 3, I have a 1, and I have a 2. But there's got to be one more in that row or in that column, right? So what number does it have to be? It has to be a 1. It has to be a 1 because the row has to be in total a 7, right? Great. So this is sort of the way that we're going to solve it. We're going to find the orientation, and then we're going to find the numbers. So let's ignore the numbers for now. Guys, I have I have this elbow piece here, right? Oh, maybe that's not the best drawing. Let me draw a new one. I have this elbow piece, and I have a, let's use yellow, and I have a T shape. Look, so if I put it like this, I'm only missing one more piece. Guys, I'm only missing one more piece. There's 3 fragments here that I can't make that with one piece. So the only thing we got to figure out now is how are we going to place these two so that the remainder is all in one chunk. So let me just move these 2 pieces out. So first, if we think about this orientation here, it's not really good, right? Well, we figured out that this red piece right here doesn't work, right? Well, this red piece right here isn't going to work either because the T shape, if we rotate it, T shape would split it into 2 chunks, right? There would be a chunk here and there'd be a chunk here. That's not going to work. So you can try and move this red piece around and look, the same reason, the T shape doesn't even fit anymore. So this orientation isn't going to work. We can try this orientation. Honestly, I think we're not allowed to flip the orientation, but here, let's draw this orientation here. Let's test a bunch of orientations out. So this is the orientation that's actually going to give us the right answer, I think. Yeah. So if we look here, I don't know if we're allowed to flip pieces, but we're definitely allowed to rotate them, right? So this is what its original orientation was, and I can just move it around. So here, obviously, I can't put it here, but I can move it right here. That's a pretty snug corner, right? So guys, where are the places I can put the T shape? How many places can I put the T shape in? Where did the T shape go? I can put it here, right? I can put it here, or I can put it here. But look, if I put the T shape here, oops. If I put the T shape here, I fragment it into 3. But if I just move it up, look how perfect that is, guys. Look how perfect that is. Oh my gosh, guys, look. We got an empty row right on the bottom. So this is our 1 by 3 piece. So if we look in the answer key, we need one of these 1 by, well, we already knew. I guess the answer key already gave it away, but I didn't. Hey, that's boring. That's boring. But now we need to know what the numbers are, right? So let's just fill in the numbers. So let's start with this small elbow piece. It's a 2, 2, 1, 2. 2, 2, 1, 2. So let's write it down. How am I going to do this? 2, 2, 1, 2, like that. Great. And this big elbow piece is 2, 1, 3, 1, 1. 2, 1, 3, 1. Let's remember that. Delete that. Okay. 2, 1, 3, 1, 1. And now for this T shape is going to be 2, 1 in the center, 3, 2, 2. 1 in the center, 3, 2, 2. Let's use 1 in the center, 3, 2, 2. So now, guys, what we know that the rows and the columns have to add up to 7, right? 7, 7, 7, 7. So let's look at this column first. Do you guys see this column? Guys, tell me, what do I need to put in this point because of this column? Look down this column. What do I need to put? Guys, look down this column. It's a 1, it's a 2, and a 3. What am I missing? It's a 1, exactly. Great, now I'm going to speed through. Guys, what about the second column? What about this second column? I mean, the third, or whatever, however you call it. What about this column? What am I missing? Yeah, it's another 1. And then what about for the last column? 1, 1, 2. Am I missing a 3, right? So the answer is right. It's A. It's 1, 1, 3. So we can circle this. And guys, hey, before we move on, we're halfway through class, and we found some hard questions. Was this question somewhat tricky? Was it trivial or was it somewhat tricky? Come on, guys. Let's see. Let's have like a poll in the chat. Did you guys like this question? Was it tricky or was it easy? It was nice. Easy, tricky, trivial, easy, tricky. Okay, great. That's a good mix. So now, Alan, why don't you bring us through the next question? So this next question is gonna look like Paul the Penguin.
Alright, bro. So here we go, guys. Now, this is a bit of an interesting flavor text, so hopefully you don't find it too cringy, but here we go. So, Paula the penguin goes fishing every day and always brings back 12 fish for her 2 chicks. Each day, she gives the first chick she sees 7 fish and gives the second chick 5 fish, which they eat. In the last few days, one chick has eaten 44 fish. How many has the other chick eaten? Okay, so this is a very, very interesting question. Let me think for a second. Okay, so here's how I'm gonna do this. We have to figure out how many ways we can add up 7s and 5s, right? Because one chick has eaten 44 fish, and that chick, the way that they ate 44 fish was by eating a combination of 5s and 7s. So basically, we have to figure out how we can add together 5s and 7s to get 44. So let me just go ahead and experiment, right? If I give that chick 7, and I assume that the rest of their days they ate 5, then it must have been that they ate 37 fish, right? Because 44 minus 7 in groups of 5, which obviously doesn't work because 37 is not a multiple of 5, right? But now you guys can see what I'm doing, because if I take 2 7s, then it becomes 30, right? And that's just 6 5s. So if the other chick eats 6 5s, 6 5s, that's 30, and they eat 2 7s, that's 44. Okay, so how many days was this? This was 8 days, and all we have to do really is just inverse every single one of these numbers, because when the first chick eats 7 fish, then you know that the second chick eats 5 fish. And when the first chick eats 5 fish, the second chick eats 7 fish, right? So we basically just subtract the number from 12, and if I move this up real quick, you can actually see more clearly what I'm doing here. So, alright, let me quickly move that up. I don't like that. Alright, bro, what is going on? Okay. Okay, here we go. So basically, the one on the bottom is the one for the second chick, the one we actually want. That's 6 7s, which makes 42, and 2 5s, that makes 10. So 10 and 42 makes 52. Okay, so one last comment about this is that the first chick ate 44. And one final trick to do it slightly quicker is that the total number of fish eaten is actually just the sum of a bunch of 12s, right? Because 12 fish were given out per day. So the first chick ate 44. The total is 12 times 8, which is 96. And so the second chick must have eaten 52. So we don't actually have to do 8 times, or we don't have to do 6 times 7. So that's one final trick to do it faster. Okay, back to you, Corey.
Alrighty, so now I guess, well, that was really fast. Now let's cover the next question, which is question 16. So a kangaroo jumps up a mountain and then jumps back down along the same route. It covers 3 times the distance with each downhill jump as it does with each uphill jump. Going uphill, it covers 1 meter per jump. In total, the kangaroo makes 24 jumps. What's the total distance that it covers? So let's take a look. Let me just draw it out real quick. We got a mountain, right? So when the kangaroo goes up the mountain, he goes up really small jumps. But when the kangaroo goes down the mountain, well, obviously going down the mountain is a lot easier, so a lot bigger jumps. So we know the total jumps is 2024. But we want to know what the total meters is. Distance, we don't know. And we know that it jumps up 1 meter each time here, and then it jumps up 3 meters each time here, right? Great. Okay, where did my slide go? There we go. So how do we do this? Let's just use algebra. Honestly, let's just use algebra. Or should we experiment a little bit? Guys, was this question easy or is this question hard? I don't think this question would be that hard. So let's not spend too long, but here's here's something that we can look at. So if the hill is 30 meters up, then it'll also be 30 meters down, right? That means I need 30 jumps here, but I only need 10 jumps here, 10 jumps. So in total, I'll get 40 jumps, but I'll only cover 60 meters, like that. So now we want to figure out, okay, well, one of the easy variables to do is just distance, right? So let's call this distance x meters, And let's call this distance x meters as well, right? So on the way there, how many guys, if this is x meters, how many jumps will it take me to jump up x meters if I jump up 1 meter per time? So guys, if this distance is am I getting the right? If this distance is 30, one of these distances is 30, both of the distances are 30, then the long one will take me 30 jumps to do, right? So this one will take me 30 jumps for 30 meters. So exactly. So if I have x meters, then it'll take me x jumps, right? So I have x meters, but I also have x jumps, right? Nice. So guys, on this side, I have x meters, but how many jumps is it going to take me? So if we look down here, when we're going downhill, there's 30 meters, but I only need 10 jumps. So on this side, if there's x meters, how many jumps is it going to take me? It is 1 to 3, exactly. So maybe I should draw a new diagram. So this is x and this is x. Meters, and x meters. So when I'm going uphill, it's going to take me x jumps. But I'm 3 times as fast. So when I'm going downhill, I only need x divided by 3 jumps. Is that right, guys? You guys all know algebra, right? I don't know what the age group of this is. I'm pretty sure they know algebra. So we need x jumps to get up, and then only x over 3 jumps to get down, because it's 3 times as fast. 1/3 the number of jumps, exactly. But in total, guys, how many total jumps are there? There's x jumps here, there's x over 3 jumps. They have to add up to 24 jumps, right? So scroll down here. We have x plus x divided by 3 equals 2024. So one way to get rid of the fraction is just multiply by 3. So let's multiply by 3. Multiply by 3. What I get is 3x plus 1x equals 672. That. Right? And then, is this right? This is right, yeah. So 4x is going to be equal to 672. So guys, remember, what is x? X is our distance, right? So how much total miles did I go? Or meters did I go? Well, I went x meters up and x meters down. So in total, I went 2x. That's my total distance, right? And the question is asking me, what is the total distance in meters that the kangaroo jumps? So I need to find out what 2x is, because I go up x, down x. So the question is asking me, what is 2x? I know 4x is 6072. That means that 2x is equal to 3036. So this is our final answer, because 2x is x up, x down. That's total meters. So it's 3036. The answer is D. You're right. Good job. Any questions, guys? Nice. Now Alan's going to bring us through the next one, which honestly, the next one is pretty fun. It looks like. What is it? Mushrooms? That's fun.
All right. So, let me move it to the top left again. So if you guys notice, I'm actually moving it to the top left on like every single question because I feel like I excessively organize stuff too much. Okay, so let me read the question out. Water makes up 80% of the mass of fresh mushrooms. So in a fresh mushroom, water is 80% of the mass, right? So if I have a mushroom, this is a mushroom from the top view, 80% of it is, and I'm just going to like draw out the information as I read the question, right? So 80% of it is water, 20% of it is like the mushroom. And then in a dried mushroom, water is only 20%. So if I have a smaller dried mushroom, water is only 20%, and then the mushroom part is 80%. Okay, so this is really what we need to do, right? We need to color code this. What do I mean by color code? Well, it's actually really simple, right? If I split this mushroom into blue and red parts, and actually you guys are already getting the answer, so I'll try to speed this up a little bit. But if we split the mushroom into blue and red parts, the red part, what I call the red part here, this is going to represent the dry part of the mushroom. And so if I draw two different diagrams here, the red part is going to be the same. But the key is this blue part, or I'm colorblind, so I don't know if that's blue, but is this blue part. It might be purple, but in the first diagram, the blue part, water, is 80%. But in this one, the blue part is actually 1/4 of the red part, right? Because in the second diagram, it represents the dried mushroom. And ooh, I don't know if you guys can see that. Okay, why is this being a problem? Okay, the chat is actually taking up a lot of space, whatever. Okay, so in the second diagram, this blue part is 1/4 of the red part. So what I'm going to do is assign areas. I'm going to assign areas. If in the first diagram this is 4, and it's an 80 to 20 ratio, then the blue part, the water, must be 16. And in the second one, it's a 20 to 80 ratio. And so the blue part, the water, is 1. Okay, so in the first one, it's 20. In the second one, it's 5. So when we dry, we lose 15 of like the mass, right? So the percentage it decreases is 15 over 20, which is equal to 75%. So we lose 75% of the mass, and it basically decreases the mass by a factor of 1/4. So the answer is C75. Uh, okay, so that was pretty interesting. Corey.
Yeah, nice, nice. That was a fun question. And the next one, honestly, the flavor of this question is really fun. Okay, let's read through it first. It's really long, but what it's saying is that we have 1 through 9. We have 9 numbers on the desk, and we have 4 people, A, B, C, and D, and they each pick up 2 cards. So there's a total of 9 cards, but 4 people come, they each take 2, so they take away 8 cards, and there's 1 card left over. And the thing is, A says the 2 cards that A has add up to 6. The 2 cards that B has, the difference is 5. C says that the product of the 2 cards is 18, and D says that one of the numbers is twice the other. So let's just write this down. Oh, shoot. Whoops. Okay, nobody saw that. Nobody saw that. Whoops. Okay. Um, All right, so A, so we got 9 cards, right? 1 through 9, and each person takes away 2 cards, A, B, C, D. So A says sum equals 6. B says difference equals 5. C says that multiply up to 18, multiply equals 18. And then D says A and 2A. So one of them is double the other, right? Yeah. Okay, nice. So, guys, let's figure out. So, there's a lot of information here. There's only 9 numbers, and there's so much information. Honestly, if you guys just spend time and just try and work on it on your own and just think about it, think it through, it's a little bit weird when I'm explaining it to you. But if you guys did this question on your own, I don't think if you spent enough time on it, I think you would be able to get it. But let's try and do this in a way. Let's figure out each person will think differently about this question, right? So let's see how I think about this, which might be slower than you guys, honestly. And I see that a lot of you guys already know. So if you got, for the people who know, do you guys want to discuss below by saying what was a critical piece of information, or which direction did you go from, or what did you fix first? In the meantime, and you can see what other people are saying in chat. But in the meantime, let's look at this. So I got my numbers. Let me see how I can do this. I'm gonna make this smaller. So I have my numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first thing is, okay, A is a sum of 6, right? And I'm gonna erase this a second. There we go. So A is a sum of 6, right? So that means that I either have 1, 5, or I can have 2, 4, and I can't have 3, 3, guys. I can't have 3, 3. And having 4, 2 is the same as having 2, 4. Having 5, 1 is the same as having 1, 5. So there's only two cases for A, honestly. It's just 1, 5 and 2, 4, right? What's D's instruction? One of the numbers is double the other. That's D's instruction. So B, the difference is 5. So I can either have 1, 6, I can have 2, 7, I can have 3, 8, and I can have 4, 9. Okay, see how there's not that many cases, right? But C is the one that piques my mind. I can either have 1 and 18, which obviously doesn't work, right? I can have 2 and 9. I can have 3 and 6. And then I can have, that's it, right? 2, 9, and 3, 6. So once again, C only has two cases as well. And then D, let's ignore D, because D has a lot of cases, right? It could be 1, 2, 2, 4, 3, 6, 4, 8. I guess it's not that much. 1, 2, 2, 4, 3, 6, and 4, 8. Okay, so let's look at this. So, hmm. Okay, why don't we look at it this way? Let's look at C. Let's use red. Let's look at C first. So if C uses 2 and 9, if C uses 2 and 9, then I can't use 2 anymore. I can't use 2 anymore. I can't use 2 anymore. I can't use 9 anymore. I can't use 2 anymore. Guys, oops. Look what just happened. A only has one case left. A has to be 1 and 5, right? A has to be 1 and 5, right? Because it can't be 2 and 4 anymore. Because C took 2 and 4, 2 and 9. So 1 and 5. That means that I don't have 1 anymore. I don't have 1 anymore. And I don't have 5 anymore. So it looks like B only has one case as well, right? Because look, two of these are crossed out for red and one of these is crossed out for orange. So B has to be 3 and 8. That means that, well, I don't have 3 anymore. I don't have 3 anymore. And I don't have 8 anymore. Oh no, guys, what just happened? What happened for D? What happened to D? Everything works now? What happened to D? What is D? What happened to D? Does D work? Can I find something out for D? I can't do 4, 8, guys, because look, I used 3 and 8 for my B. There's 3 and 8 right here. I can't use 8. What happened to D? Can I get is it working or is it not working, guys? Yeah, Emma, you're right. We started with the wrong one. It's cooked. That's what it is. Good one, Isaac. I like it. Yeah, never mind. Nothing works for D. Exactly. There we go. Yeah. You guys were wondering where the chat went, guys. So, guys, what did we start with? Let's backtrack. We started saying that, okay, we started with a star saying that C takes 2 and 9. Well, 2 and 9 obviously doesn't work. So let's cross out 2 and 9. And let's say we use 3 and 6, okay? So the same thing, guys. 3 and 6. Well, don't have 3, don't have 3, don't have 6, don't have 3 and 6. Yeah, that looks about right. So now, ooh, we don't have any singular ones. So guys, we have to branch out again. We have to branch out again. Huh. So this time, hmm, let's see. What do you guys want to do? Do you guys want to look at A or do you guys want to look at B? Guys, everybody type A or B in chat and I'll see which one is more. Everybody type A or B in chat and I'll see which one's more. A, Wait, guys, type A or B in chat. Okay, I see a lot of A's. So let's look at A. Okay, so first of all, we know that it has to be this red one, right? So I can just ignore. That means it has to not be these because it's guaranteed, right? The red is guaranteed, so these are guaranteed gone, right? So now what do I have left? Red. So let's consider our red. Let's say I use 1 and 5. So this is casework again, guys. We're not sure. Let's assume it's 1 and 5. If it's 1 and 5, actually let's assume it's 2 and 4. Why? Okay, let's assume it's 2 and 4. It makes it easier. Then I don't have 2. I don't have 2. I don't have 2. I don't have 4. Oh, what happened, guys? If I use 2 and 4, what happened to D? I don't have 2. I don't have 2. I don't have 4. What happened to D? It's all over, right? It's broken, right? So what does this mean? Guys, what does this mean? Whoa, whoa, whoa. Guys, look at D. Look at D. What happened to D? Try the other one. Exactly, Emma. So that means that for our A case, we must not have this one. We have to have the 1 and 5. Yeah, no possibilities for D. That means I have to have 1 and 5, right? So that means I can't have 1 and I can't have 5. So, oh, okay. Wait, 4. Okay, great. So now, okay, we got more cases. But this is guaranteed, right? This is guaranteed. Like, this is the only possible case, right? So I can erase everything else. Guys, we have two choices, two choices for B and two choices for D. But obviously one of them doesn't work. So which one should we try first? Which one should we try first? Yeah, let's just try 2, 7 first. So I have 2, 7, and then I have 4, 8, and then it works out, right? Then I'm missing 9. That's what's going on. But let's see the other case. So if I have used the other case, if I use 4, 9, then look, I can't use 4 and I can't use 4, so it doesn't work. So it has to be 2, 7, and 4, 9 doesn't work, right? Yeah, exactly. So I have to use 2, 7, and then I can't use 2, 4, and then I just use 4, 8, and then I'm missing 9. So that's my answer. Does it make sense, guys? So it's sort of like this casework, but you have to pick and choose where you start because that's what makes it fast. Nice. So the answer is going to be B, 9. Good job. All right, Alan. If you want to speed run the next question, that's great, but we have 4 minutes left.
Alright, bro. So, okay, let me check real quick. Actually, are we supposed to finish, finish the test, or are we supposed to stop when the time stops?
Stop at the time.
Okay, so here's the thing, guys. It appears that we're pretty bad at math because we did not finish the test in time. So
Hey, that's okay. Wait, it's just because like, the live streams usually don't finish the test. Honestly, we're at question 22 and we have 1, 2, 3, 4, 4, including this question, 5 more questions. That's not bad. That's not bad.
Alright, but like, guys, don't laugh too much, alright?
Yeah, don't laugh at us too much.
Come on, man.
Yeah,
Alright,
we're growing
so,
up.
okay, let's do the last question real quick. Alright. So, let me quickly read out the last question, and then you guys, like, if you could hold on for, like, one last effort, and, like, pay attention for one last effort, that would be much appreciated. Alright, here we go. So, Thomas wants to shade 2 additional squares on the diagram shown, so that the resulting pattern has a single axis of symmetry. In how many different ways can he do this? Okay, so, once again, we have another 4x4 square, and the key thing in this question is that we're looking at axes of symmetry for this square. So the axes of symmetry, if I draw out just like kind of separately, there are 4 axes of symmetry. There's 2 diagonal axes of symmetry, and then there's a vertical and a horizontal axis of symmetry. So let's put it this way. We can take 4 cases based on the 4 axes of symmetry, right? So after we add the 2 additional squares in, there are 4 cases for what the axis of symmetry is, right? So let's say I take case 1, right? So I'm gonna go ahead and erase this stuff that I just drew, so just keep that stuff in your head. So the first axis of symmetry, and I'm going to erase each case after I finish it. The first axis of symmetry is vertical, And in the vertical axis of symmetry, there's really only one way to do it, right? I have to add this square and this square here, because in a vertical axis of symmetry, if I have something on the left, then I have to have its mirror on the right. So for vertical axis of symmetry, there's +1 case. The second case is the horizontal axis of symmetry. And in the horizontal axis of symmetry, I'm going down like this, and I have to reflect across this horizontal line downward onto the bottom half. And there's only one other case for this, right? So for horizontal, it's +1 once again. Okay, so now there's two more cases, right? So we've done vertical, we've done horizontal. Now we have to do the main diagonal line of symmetry, the main diagonal. And so on this main diagonal, once again, we just have to reflect across, right? So we can go, or we can reflect across the first square, because the first square, its mirror has to also be on the left half, and then we can reflect the second square, and the second square, its mirror has to be on the left half as well. So that gives us +1 more case, right? Because this is the only case we can do. We must add these two additional squares. Okay, finally, and that was the main diagonal, and now I'm just going to call this one, like, I don't know, other diagonal. So finally we have the other diagonal. The other diagonal is this one. Alright, so on the other diagonal, we have to reflect the first square across, because, again, we have to make this line become the line of symmetry when we add the 2 second squares in. I see Helen says, I don't think I get the question. Basically, what we have to do is, we have to add 2 squares in, and create a line of symmetry, right? We have to add 2 squares so that the resulting 4 squares are symmetric across some line, some axis of the square. We have to add 2 squares in so that some 4 squares are symmetric. So in this case, I have to add in the third square down here, because if I want it to be symmetric down this other diagonal, then I have to have the other square be present, because if a square is here, then its mirror is also present. So finally, for other diagonal, as Missy says, there are 3 possibilities, right? Because I can have the final square be anywhere along the final diagonal, because I still have 1 more square to add in, 1, 2, and 3. So for the final case, there are 3 different possibilities, and I won't draw out the possibilities because that's, like, kind of annoying. But yes, the answer is E6. Okay. So 2 minutes over time. But hey,
Hey, that's not bad,
when
guys. We got another
yeah,
question.
when I finish tests, sometimes what I'll do is, like, they tell you to put your pencil down. Like, if you guys have taken tests before, they'll tell you to put your
Yeah,
pencil
yeah.
down, and, like, you just don't put your pencil down and you finish the last question because they don't catch you, right? If you make sure that
What?
they don't catch you, no,
Hey,
if they
hey,
make sure
hey,
that
hey, bad advice. Oh, what happened to my
if you
screen?
make sure that they don't catch you, you can, like, spend, like, 5 extra seconds to, like, do some
What?
final work, right? So
Terrible advice. Wait, wait, wait. If they say put your pencils down, you should put your pencils down. You're gonna get caught for cheating.
all right,
Whoa,
right.
whoa, what
So
do you mean? Oh my God.
okay,
Um,
okay. So I think we didn't get to
it's
the
okay,
final
it's
few
okay.
questions, but I think that concludes the live solve, right?
Yeah,
So
thank you, everybody. Bye-bye, guys.
so
Bye, thank you so much.
yeah, thanks everybody for coming. If you enjoyed it, then you can come to, like, future live solves. Maybe one of us will be there. That'll be very
Oh,
interesting.
yeah, definitely. We come to future live solves and look into more live stuff and look into more Math Kangaroo stuff. These questions are pretty fun. You should do them on your own. Hey, we're a little slow, but you guys can do them on your own. They'll be fun. Bye-bye,
Also,
guys. Bye-bye.
we are if you enjoyed, I may shave my head in the future. So
Oh, oh,
yeah,
that's
no,
looking
wait.
risky.
I may be joking or I may not be joking. So you'll never know. I'm
Guys, you guys
saying
have to
this,
tune in now to just
yeah,
click
I'm making
Schrodinger's
a
cat. You know.
extra suspense, right?
I
So
know. Bye-bye,
I can't
guys.
even see what the chat is saying, actually.
We're saying
Okay,
best Zoom class. Bye-bye. Bye, math people. Bye, math people. It was nice seeing you guys.
okay. Um.
Bye-bye. Anything